Good morning. Still just about morning. I'd like to welcome all of you. Thank you so much for being here. My name is Brian Roche, and we've got a little bit of a different format today. We have a panel session, and I think we've assembled a great panel to talk to us about OpenStack and deploying OpenStack and some of the problems that we've seen, and they're going to share with you some of their lessons learned. So I think this is going to be a really fun session, and it's for you. So we want this to be interactive. We'll kick things off with a little bit of introduction of what are the challenges that we've seen? What problems are we trying to solve? And then we'll go deeper into how we've solved them. And then most importantly, in the last section, I want to hear from you guys. So I'll walk around with the microphone, and you can give us your input, ask the panel questions. I think they're ready and equipped to answer anything. And if we don't get to your question, as always, we have a booth here. So the benefit of this session is we kick it off, we tee it off, and we get a lot of ideas and thoughts, and we'll continue discussions at the booth. So with that, let me kick off by introducing our panelists. So on my right, your left, we have Drew Dimmick, and Drew is a business development manager for all things cloud native, right?
That's right.
Pretty much. Right here is Mo Khalid, and Mo is our senior technical marketing engineer. Very deep knowledge. Ramiro, Salas, you're here. Thank you so much for joining us. You're a Cloud Foundry advisory architect with Pivotal. So let's kick it off right away. Drew, let's frame the challenges we see. What kind of problems are we seeing out there? You're out there talking to customers all the time. What are we solving for?
Sure. Thanks, Brian. So when we get started with this program that we built, what we call it Native Hybrid Cloud, we went out and did a bunch of customer interviews and did a lot of market analysis. That was my job and has been my job over the last 2 years at EMC. And we found that a large number of customers were actually deploying Cloud Foundry on top of OpenStack. And so we went and looked at that as a good market opportunity for us. We had some strategic investments inside of EMC where we went out and bought a company by the name of Cloud Scaling, which does a lot of work with OpenStack. It's pretty well respected in the OpenStack community. And we took a lot of the learnings from that and then said, hey, how do we make Pivotal Cloud Foundry run as a first-class citizen on top of this platform that Cloud Scaling has? So we started that with kind of the genesis of our idea. And then we started to go out and work with customers and work with Pivotal's resources to understand what we need to do to actually take PCF and make it run not just adequately, but run in a production-ready mode. So this is things like taking care of the backup, the restore processes, to make sure the platform stays up if you have some sort of failure in the infrastructure. All of those things were taken into consideration as we built out our solution. And what we want to do here today is really share that experience with you so you understand what's ahead of you if you're embarking on a program or a project to take PCF and implement it on top of OpenStack. We had a lot of really good learnings. I think it will help you accelerate your journey, and that's why we have the panel here today to really talk about that. So we can get into the technical details with you, all the different opportunities that we see in the market, and some of the use cases that our customers have put into place on top of the platform that we've built. So thanks, Brian.
Thanks, Drew. Mo, I'm going to touch on you next. So I think clearly an opportunity as we try to deploy OpenStack, that can be a challenge to get Cloud Foundry and OpenStack to work together, right? Cloud Foundry expects certain configurations. What are you seeing out there? What kind of challenges do you see on a more technical level?
Absolutely. So I'm going to work with Drew here. As Drew was mentioning, as we've been talking to customers, we've also been deploying the solutions. So taking a step back, right, when you walk into the customer's site, let's say, assuming that the customer is OpenStack savvy, typically it doesn't happen that way. If they based on the solution they buy, but typically when you go and have a conversation around, hey, remember OpenStack is a classic framework, right? It's a cloud framework, right? It has multiple projects. It has things for compute called Nova, for storage it's called Cinder, for Swift it's called. So the customer does not only have to consider all these different projects because he can pick and select which project he's going to start with and then start designing around it. But think about it's just a control plane, but at the back end, they might have things like Cisco switches for Neutron, for networking. They may have something like EMC storage, or it could be EMC or NetApp or Ceph storage. So they have to make sure that there's a compatibility matrix. Again, this is the assumption that they haven't bought our solution. Let's assume this is the first conversation. So all these things have to be considered by the customer, not only from designing implementation, but then it starts getting into operation aspect of it. How do you operate it? How do you do backup? How do you do availability? So typically, as Drew was mentioning, we are out there to just deploy Pivotal Cloud Foundry on top of OpenStack and just say, hey, walk out of the door, done 2 days, but that doesn't happen. Now you're getting into the customer's discussion of designing and planning around OpenStack. So one of the considerations that we do tell the customer is, hey, it would be great if you have, if you're going to deploy Pivotal Cloud Foundry, make sure that you do work with some of the good reference architecture program out there with someone like Mirantis or someone like Canonical or someone like EMC, of course, so that they have a good reference architecture program so that they can help you build and deploy so that it becomes easier for the services on top to run on top of OpenStack. So that's a very key. Or absolutely, as Joe was mentioning, they can absolutely buy our solution. It's a complete turnkey solution, so you don't have to worry about the day one operations. So then we can jump, the Pivotal Cloud Foundry folks can come in and we can say, okay, then we start considering all the other aspects. But before I go further about the Pivotal Cloud Foundry on top of OpenStack considerations, I'm sure Ramiro has a little bit more thought process on that.
Yeah, thanks.
Yeah, I think let's stay on day one. So you have a, let's change the lens a little bit, right? So from a PCF and a Cloud Foundry perspective, how do we get all this to work together? You have a very global, interaction with customers. Let's share some of the challenges that they're seeing.
Yeah, we've been doing deployments in the field for the last 2 years. Before we had Ops Manager, actually, we were doing everything directly via Bosch. The beauty of OpenStack is also its problem. The beauty of OpenStack is it exposes this well-designed northbound API that Bosch can come in and consume without any problem. The problem is that creates an abstraction that makes pretty much invisible what's going on underneath. So that can be a problem in the sense that the expectation is that the behavior of the system is going to be such that it's going to be exactly the same no matter where you go. But that never happens. In our experience, pretty much every implementation that you see out there in OpenStack, every one of them is a snowflake. They're all unique. And you can call the API of OpenStack and you can expect a certain response, but the behavior ends up being different in different clouds, in different environments. And that's problematic for us, right, from the perspective of the Bosch CPI. Bosch has a lot of expectations and exercises a lot of pressure in OpenStack itself, in the API. So what we see there is that many times we see unexpected behaviors. Let me give you an example. Bosch has certain expectations in terms of timeouts for deleting a volume, right? When you do a compilation VMs and you're deploying Cloud Foundry, you start deploying like 11 VMs by default to do the compilation, and then you delete those VMs. Right? Each one of them have their own volumes, right? So the deletion process is an API call. You just basically call Cinder. And you expect that if the system has a reasonably well-engineered backend in the Cinder side of things, the deletion is going to happen in a matter of seconds, or maybe even asynchronously. That would be even nicer. But suddenly we realize that some backends, like LVM, for example, they do a DD def 0 against the volume before they delete. That means that can take 30 minutes, and Bosch times out, right? So things like that are completely unexpected behavior. That should not really be the case in a practical sense, right? I mean, the beauty of OpenStack is that it exposed this API, and we expect that it's going to work the same way, but it doesn't, right? Those are some of the things that we see in the storage side of things. In the compute side of things, you see things like the expectation of a certain format for the virtual machine, right? So some customers are using vSphere, for example, as a backend, as a compute backend for OpenStack. But obviously, we don't have a stem cell for that, right? So we need to create a stem cell that has vSphere format. No, it's not raw, it's VMDK, but it has also the metadata that corresponds to OpenStack. When you mount the disk, which is a very normal operation in Bosch, when you mount the disk, the format of the disk, the name of the devices are different, right? In the case of Zen, is /dev/xvdb, right? In the case of KVM, is /dev/vdb. In the case of vSphere, /sdb. So the monit scripts are going to change internally. They're not going to be the same that you expect. So then you have yet another challenge, right? The compute aspect of that is also going to be different. You cannot just send something to Glance and expect that it's going to boot a VM the way you expect it. It's different. So, and then we can go into networking, which is going to be another I'm pretty sure you can. In the networking side of things, the neutron behavior is very different depending on the backend that the customer chooses, right? We see all sort of issues out there with poorly deployed network environments, expectations around MTU in environments that are not very well engineered, let's face it. I mean, many times what we see is that customers are experimenting with OpenStack. They're learning as they go, and then they come in and they put Cloud Foundry on top. You have one complex system on top of another. That's a really, really bad idea. One thing that we tell customers is that, look, give us a very stable OpenStack environment, learn it first, learn those best practices, how to manage that, and then we can come in and just install our thing on top.
Okay. So I guess with a show of hands, how many people here would consider themselves operators? How many would consider yourself a developer? Okay, good. How many just wants the platform to work so you can deploy your code? Okay, all right, good. So look, I can go grab OpenStack, right? I can go get it. Are you guys, overinflating the problem? Like, how hard is it really? What will my experience be like when I go grab all the bits? I start playing with Swift. I start playing with Cinder. Like, what are some of the on the ground sort of rubber meets the road challenges I'm going to see?
All the problems that Ramiro talked about right now, right?
Yeah.
So as I said, you have to design and plan that this is just not like getting in the trunk, downloading the bits. It's not like DevStack running on your laptop and things just work. Oh, this is awesome. This is easy. Let me go deploy it. It's not that way. You got to have, as I said, each of these are separate projects, and each of these have the separate code base. So and then they bring them together. You can bring them. You can go and compile and go ahead and start deploying it. But think about also things like upgrades. Now you're going from, let's say, Kilo to Liberty. Mr. Customer, if you're doing it yourself, are you going to be testing this? How are you going to test this? Because each of these are different projects, remember. So you have to take that into consideration. So those are some of the key challenges. It's just like, it's not like a science project. If you really want to get into production, you have to know things. So which is why it's better to buy a prescriptive turnkey solution. If that's, as I said, all you need is deploy code, then you need to buy a very prescriptive turnkey solution, as Drew was mentioning. But let's assume, for all intents and purposes, the customer knows his OpenStack, knows those things really well, he's done everything. But then you come with the Pivotal Cloud Foundry, as Ramiro was mentioning, then you still have to start talking about, as he said, designing and planning, right? For example, let's assume that things like, you say, hey, you know what, I'm going to start from dev, but I also want to scale it to production. So now you have to start talking about sizing the Pivotal Cloud Foundry environment, right? You got to worry about how many virtual machines, how much storage, how much Cinder storage. Do you have to replicate it? Volume snapshots, which again is a capability of Cinder. Is that capability present within the underlying OpenStack ecosystem? So you got to start thinking about all those and then map those quotas. So within the OpenStack, what you have to do is define a project. Within the project, you say, hey, this whole quota, which I'm going to allocate, is for Pivotal Cloud Foundry. So when Ramiro goes in and says deploy, it should deploy easily because the quotas are already allowed. So those capacity aspect has to be planned really well for you to go and deploy. So assuming the OpenStack is good, then the conversation starts about sizing aspect of it. Once you finish up sizing, then the question comes about authentication authorization, because OpenStack has two ways you can authenticate and authorize. One is Keystone version 2 and Keystone version 3. So if you're running anything, let's say Pivotal Cloud Foundry, I think, when did you guys start supporting Keystone v3? Recently. Yeah. So let's assume,
1.6, I think.
Exactly. So let's assume you're running 1.5, then you have to consider, it's only Keystone v2. So if some of your other vendors are supporting Keystone v3, then you have to start thinking about all those parameters when you start deploying those. If it's all Keystone v3, if it's Kilo release or Liberty release, and everything looks great, so that is the conversation we talk about to the customer about authentication authorization. Then there's certain flavors. So flavors, I think about it like Amazon, like M1 small, M2 small. So by default, there are specific flavors that OpenStack brings about. But those flavors might not match the sizing aspect of what Pivotal brings up. So we want to make sure we talk to the customer about the different flavors so that it helps on the deployment aspect. So it makes it easy for the Pivotal Cloud Foundry aspect to deploy. So Ramiro, you want to add some more things? Yeah.
Yeah, super important to emphasize the flavor thing, because actually when we go in and deploy, we call the flavor, but we don't do checking. We don't do boundary checkings. We don't know. We assume that the flavor has certain size, but we don't check that. The CPI doesn't have that job. It just takes the name and deploys based on that. So it's a pretty important thing that to verify ahead of time. Cloud Foundry doesn't create anything on OpenStack. And OpenStack is typically an environment which you could create a lot of things programmatically, but we decided to take the approach of being consumers. So from that standpoint, we go out and have the expectation that certain things will be there, like specific networks or VIPs or things that we're going to need to get from the environment. But the backends have different ways of dealing with that. I would say probably in terms of best practice, the most important thing to recover in case of a bad situation that can happen in an environment is to make sure your Cinder implementation is absolutely rock solid. The reason for that is that Bosch does a lot of magic, right? It's a fantastic piece of software. But at the same time, it's sometimes we have unrealistic expectations in terms of what Bosch actually can do. Bosch can recover of almost any situation that occurs in the underlying environment, with the exception of losing some of those key volumes that are attached to those VMs. Those are the volumes that contain the information. For example, your blob store, right? The blob store contains all the blobs, right? So if you lose that, well, you're not going to have those blobs anymore, and you're going to have to recreate the environment, or you repush all the applications, right? So it's going to be tricky. So what you need there is making sure that regardless of your environment, making sure that your Cinder-based backend is absolutely rock solid, well-designed, well-engineered, and in case of a failure, you're not going to lose those precious volumes, right? And if you do, then have a proper IIS-level backup and restore procedure so you can recover that and recover your environment based on that. Bosch can recover in almost any situation. It's not going to try to clean the VMs. It's not Puppet, right? It's not going to try to fix anything. If the VM is not working, it's going to wipe it out, put a new one in, remount the disk. So that's the expectation. That's what Bosch does. Very, very powerful piece of software. But at the same time, it needs to rely on the underlying layer. It needs to be properly set up.
Absolutely. So let's maybe just take a pause for a second.
Sure.
Any questions in the audience? It's always tough to go first. Let me see if I can grab that. Thanks.
Thank you for the introduction. It will be very nice. So what you are talking about, networking, storage, how to configure that, there are many different options. Do you have some, very clean do and don'ts, how to configure something or what to avoid? And then we as an organization can work with these do and don'ts and find what we have and find, overlapping.
Yeah, good question. Who wants to take that? Ramiro?
Yeah, I actually put together a document that is publicly available. It's a Google Doc that we try to keep it updated as things go along. It's specifically on open source Cloud Foundry, so it should work on any Cloud Foundry implementation, not necessarily pivotals. And it basically gives you the most basic requirements that need to be out there, right? What things are absolutely mandatory that you have in the environment, what are the best practices for each one of them, and what you should avoid. I mean, it's not super comprehensive in terms of do's and don'ts, like very prescriptive, but it gives you a very good layout, a very good framework, and we can make that document available, right?
Now, where is that?
It's in a Google Doc. And
okay,
once
cool.
you find the URL in Google Doc, you better save it because
okay.
You know how it is.
All right. So we'll share some links where you can
Yeah.
find this information.
Just to
afterwards
add
when
to
we get
that, again, just to get a brief of how the design should be, what should be considered, I would also look at docs, Cloud Foundry docs, or pivotal docs. There's an OpenStack section. It actually goes through, hey, when you do sizing, make sure you consider all these elements. So I would at least tell all my customers, make sure you at least are well-versed with that aspect of it. So it's got some great documentation. Just to add to the documentation also, as I was talking about sizing, remember when you have this conversation with the customer, with all the OpenStack stuff, there's also about the concept of sizing, right? So what you have to figure, remember Pivotal recommends that, hey, if you want to run all the elastic runtime components, run 2 or more. So make sure that you do take that into consideration when you do your sizing aspects of it. Again, as I said, the docs are pretty well documented, but the do's and don'ts are not especially clear, but that's typically patterns that you learn. Even for us, when we went back to a customer, we learned all these patterns, like backup. Like, hey, Cinder, like Cinder today, if you see there's a project now to backup Cinder, it's called Raksha in OpenStack. So we are planning to look at those kind of things to automatically back up to our endpoints, but it is open. You can back it up to any endpoint within the industry if you have. So those are things that you can do, definitely consider. As I was saying, if things get deleted, you assume things are coming back up, don't assume those things. So I'll also point out, you guys are from Comcast, right? There was a fantastic presentation by George, I think. So he has this thing called, he says, we test for failures continuously using Lemur, like Chaos Lemur. Basically do that. I tell my customer, after deploying, just keep doing this process so that you will learn from failure so you can size accordingly and learn and write your patterns out. So it's helpful for not only for us, but also the open source community, lessons learned from the customer. I can keep going.
Very good, yeah.
Sure.
Any more questions?
would you recommend using any tooling like, say, HashiCorp's Terraform to set up resources in OpenStack to deploy CF? You mentioned that OpenStack is very snowflake-like, so I don't know if that works.
Mo, you want to take this? Or?
So we work quite a bit with Terraform, actually. It's getting better, right? Terraform is very good, actually, as a concept. It's fantastic. We can use either heat to set up the environment, like it's CloudFormation compatible, or we can use things like Terraform. It's transparent to us, technically speaking, right? I mean, how you actually provision those resources, you can do it by hand if you want. What Cloud Foundry expects is that those things are there by the time of installation. The thing is that ultimately you want to automate all this, right? So using a tool like Terraform is actually a very good idea. I think the tool, in our experience, was a little flaky until recently. I haven't tested it in a few months. But it's getting better and better with every release. So that's one of the good things that we like about HashiCorp in general. The software quality is very good. So if it works for you, if you test it, making sure that the deletion process also works. I mean, we've seen some things on Terraform that it leaves things that are not very clean, right? When you delete things. So keep an eye on that part. But in general, we like it.
So a lot of challenges. Everything is unique. What's your perspective, Drew? How do we streamline this? Because we don't like unique deployments. It's a lot of work, right? How can we get the whole stack to hang together so that we can focus on what really matters, deploying our applications so our customers can derive value?
Sure. So what we achieve with native hybrid cloud is that developers can start with CF push. And that's our entire objective with the program. We've achieved that by doing exactly what you said, Brian, which is eliminating the snowflake concepts here. We've taken the best practices and the learnings that we've done through our betas and DAs of the solution. We've embedded that into that and made that repeatable over and over and over again. And so my advice to you, even if you weren't to go with a packaged solution from a vendor like EMC, is that you get into the same sort of methodology so that you're not building snowflakes. Even inside of some companies that I've gone to visit, as I've gone through this journey, I've found that companies might have multiple OpenStacks that are deployed in different ways for different workloads, and they've created their own snowflakes within the snowflakes, and that's even more complicated, and it makes it very hard to do what ultimately you want to do is be able to completely repave the infrastructure on a regular basis when you get security updates, when you get application updates, when you get service updates. It's not a I'm going to patch in place approach. It's a I'm going to replace the entire infrastructure software layer approach, which is a fantastic way to do it with all the concepts behind that. But if you're starting with snowflakes, you're going to spend a long time dealing with what I call whack-a-mole, just going around and banging down problems and trying to figure out what caused my repave to fail. You want to be able to completely deploy from an authoritative source and rebuild the environment from the tin up. And that's what we focused on with native hybrid cloud, of course. But even if you're doing this yourself, you want to be able to engineer that approach so that you can repave with confidence and know that, hey, I can just stand up an environment and boom, it comes right back within a very short amount of time. We get that to a day where we can get the whole thing up and running from the OpenStack deploy all the way up to the CF login.
So native hybrid cloud, not just for day one, also day two operations, upgrade, maintainability. What about monitoring?
Sure, so that's the other part of it. So of course, whenever you deploy any system, and this is one of the great observations that we've had in the program, is that IT generally still owns this platform, and they still have to do what they've always done, which is go and monitor it, make sure that it's behaving right. You have to do capacity planning. Some folks are really focused on chargeback and being able to bill and meter for usage of the platform. That varies by customer and varies by industry. But these are all important things that you have to think about. It's not just about getting developers being able to push code, but then, hey, I want the developers to be able to push code with confidence, knowing that the platform has the capacity that they need, does the performance that they need. And so we've built into our solution set, of course, all of that, and that's part of, and we've actually just used a lot of the other references that are out there. There's great solutions in the market, like Datadog has a great set of optics into Cloud Foundry. We took that, we learned from that, we shared some stuff back. It's been a great learning. The day two operations of the platform is a really critical thing.
So the product manager says it works and it solves problems. Does it really solve the problems?
Yep, it does. So So as I was saying, we know the Pivotal Cloud Foundry part. We know it works really well. We know you can do a CF push. Hey, here's my source code. Go do some things, right? All this works. So what our focus was day one deployment, which we talked about, and sizing and stuff. But at the same time, we wanted to make sure that things like availability. Like, for example, when we started talking to customers, the question was, hey, what happens if my node failures? Then you start educating them, hey, Pivotal does certain things. Like what happens if a piece of ops manager goes down? Guess what? You're dead. So how do you back it up? So we do take that into principle. We back up piece of ops manager. If you're using ops manager, if you're using Pivotal, right? If you're using ops manager, then how do you restore it back? So those kind of scenarios. Things like availability zone concept. For example, OpenStack now supports, Bosch CPI does support AZs. So if you have 2 racks in 2 different rooms, if one rack goes down, we can definitely do that. So those kind of design patterns is, again, we've started putting that together with the customer, saying not only node failure, rack failure, things like, as we already talked about, backup and restore, monitoring and reporting. So absolutely, Brian, as Drew was mentioning, that has been our focus,
right.
And as we talk to customers, we're trying to strengthen the day 2 ops, because at the end of the day, we have to make developers and operators come together so that the developer can keep coding, and for that, we have to keep the stuff running. And so we've been focusing more on that.
So, Ramiro,
Ramiro, you want?
who's using this today? Who's really out there solving problems with this solution?
Well, customers that have large environments, actually, some of the largest implementations that we have in Pivotal, they're actually OpenStack implementations. They're huge. And none of them are using a distro, right? They're all building it from scratch, but they have an army of engineers, and they have a lot of time to really come up to speed and learn the processes and really debug and learn how to operate OpenStack properly. I think the solution that you guys have is it's a turnkey solution. It's like, from my standpoint, as Pivotal, just give me something that works, right? That's what I want to see. I don't want trouble with the IIS. The IIS needs to respond to my commands. I like to have an infrastructure that is programmatically controlled. That's the whole objective of using something like Bosch. Have a request, making sure the infrastructure does what it's supposed to do. I don't want to have to deal with that, right? So I need the underlying layer to behave the way it should behave. There's a few things that I'm still concerned about, which is the quality itself in the OpenStack piece by itself, like Neutron, for example. Neutron is a delicate piece of software. It needs to be well engineered. We've seen situations where Neutron itself crashes, right? In that case, you lose the network. So Bosch is going to lose, obviously, the connection with the agents, and so what's going to happen at that point, right? So partial failures are probably the most difficult thing to deal with in the whole environment. So you may have orphan VMs and so on. Bosch is learning over time how to deal with things like that, and it's improving quite a bit, and the CPI quality is actually quite good right now. So I'm pretty confident that those things are going to happen less and less. But the biggest recommendation in general for customers is learn OpenStack really well, have those operations down to a fine art. It's not vSphere. I mean, people that have been doing vSphere for 10, 15 years, vSphere is one of the most stable environments you're going to find out there. It behaves pretty much the same way no matter where you go. But if you're going to go into OpenStack, and a lot of people is going from vSphere into OpenStack, they have the expectations that it's just going to behave exactly the same way, and it's not. It's not. You got to be careful with that kind of thing, right? So it's learn those things first, learn to operate OpenStack properly, and rely on an environment that is solid. And I think the solution that you guys are offering, it solves exactly that kind of problem, right?
Good, awesome. Well, we're out of time, unfortunately. 30 minutes is, it's tough to kind of get all the technical detail across. And so hopefully we can have further discussions around this at the booth. We will be posting, we'll put it on the dojoblog.emc.com. And if you're looking for anything to do this afternoon, we have a couple of good sessions coming up. We have Paul, who's going to be talking about persistence, who is here. Maybe he's on his way to a session. That's at 12:20. And then I'll be talking about the EMC Dojo and our adoption of new work patterns, moving to a DevOps culture and continuously delivering so we can deliver customer value. So this is kind of a retrospective 1 year later. Where are we with the Dojo and our transformation? So I want to thank our panelists. Ramiro, thank you. Mo, huge knowledge. Thank you for sharing that with us. And then, of course, Drew, loved hearing about NHC. And to all of you, thank you very much. We appreciate it. Thank you.